Hello students. So we are discussing some important concepts for the 2021 NEET and Karnataka CET examination. So I have selected few important concepts from where we are getting the questions in the competitive examinations like NEET and Karnataka CET. My next concept is on dimensional analysis. I guess you know the three important applications of what dimensional analysis. So the dimensional analysis is used for the three purposes. The first application of the dimensional analysis is you can check the correctness of a given equation. Given equation, the scientific equation, whether it is dimensionally correct or the dimensionally incorrect, such a type of equations we can check with the help of what? The dimensional analysis. So what is the first application of the dimensional analysis? To check the correctness of a given equation. We can easily check the correctness of a given equation with the help of what? The dimensional analysis. So second application of dimensional analysis is we can convert the unit of a physical quantity from one system to another system. Suppose if you know the value of force in SI system, we can determine the value of force in CGS system. Suppose if you know the value of the energy in a SI system, you can convert that value into CGS system. In general, the unit of physical quantities from one system to what? Another system, we can convert with the help of what? The dimensional analysis. That is the second application of the dimensional analysis. Then the third application is we can derive the correct relation related to what? Physical quantities. Say for example, a time period of a pendulum. It depends on length as well as acceleration due to gravity. How time period of a pendulum depends on length and acceleration due to gravity, that can be derived with the help of what? Dimensional analysis. If we take one more example, say for example, centripetal force depends on mass of a body, velocity of a body, a radius of circular path traced by the body. So how the centripetal force depends on mass, velocity and a radius of a path. So these all things we can derive with the help of what? The dimensional analysis. So tell me, what are the three applications of dimensional analysis? We can check whether given equation is dimensionally correct or incorrect. We can check the equation with the help of dimensional analysis. Second one, we can convert the unit of physical quantity from one system to another system. The third application is we can derive the correct relation related to the physical quantities. But in this class, let me consider some of the concepts from the dimensional analysis where we can find questions in the examinations like what? Karnataka CET as well as NEET examination. So first type of example is based on the first application of what? The dimensional analysis, that is to check the correctness of a given equation. Say for example, we have the equation called V is equals to what? U plus AT. So according to principle of homogeneity, this equation is said to be correct provided all the terms in this equation should have the same dimensional formula. ಯಾವುದಾದ್ರೂ ಒಂದು ಈಕ್ವೇಶನ್ ನ ಡೈಮೆನ್ಷನಲಿ ಕರೆಕ್ಟ್ ಅಂತ ಅನ್ಬೇಕಾದ್ರೆ ಕಂಡೀಷನ್ ಏನಂತಂದ್ರೆ ಆ ಈಕ್ವೇಶನ್ ನಲ್ಲಿರುವಂತ ಎಲ್ಲಾ ಟರ್ಮ್ ಡೈಮೆನ್ಷನ್ಸ್ ಸೇಮ್ ಇರಬೇಕು, ಡೈಮೆನ್ಷನಲ್ ಫಾರ್ಮುಲಾ ಸೇಮ್ ಇರಬೇಕು. ದೆನ್ ಓನ್ಲಿ ವಿ ಕ್ಯಾನ್ ಸೇ that equation is dimensionally correct. For example, here we have the equation called v is equals to u plus at. This equation is correct provided dimensions of u should be equals to, dimensions of v should be equals to dimensions of u should be equals to dimensions of what? at. ಇಲ್ಲಿ ಎಷ್ಟು ಟರ್ಮ್ಸ್ ಇದಾವೆ ನನಗೆ? v, u and at. ಮೂರು ಟರ್ಮ್ ಇದಾವೆ. ಟೋಟಲ್ I have 3 terms. This equation is said to be correct provided dimensional formula of v should be equals to dimensional formula of u which is equals to dimensional formula of at. ಸಿಂಪಲ್ ಸೆನ್ಸ್ ನಲ್ಲಿ ಹೇಳ್ಬೇಕಂದ್ರೆ ಎಲ್ಲಾ ಟರ್ಮ್ದು ಡೈಮೆನ್ಷನಲ್ ಫಾರ್ಮುಲಾ ಸೇಮ್ ಇದ್ರೆ then only that equation is said to be dimensionally correct. So for checking what correctness of the given equation, we are making use of principle of homogeneity. Which principle we are using? The principle of homogeneity. Principle of homogeneity. So this principle of homogeneity is a principle which is used to check whether given equation is dimensionally correct or incorrect. So let me focus on the statement of the principle of homogeneity, because our next questions completely depends on the statement of what? The principle of homogeneity. So tell me, what is the principle of homogeneity? According to principle of homogeneity, in a given equation, 2 or more physical quantities can be added, 2 or more physical quantities can be subtracted, 2 or more physical quantities can be compared, provided they should have the same dimensional formula. ಎಂತ ಎರಡು ಟರ್ಮ್ಸ್ ಆಡ್ ಮಾಡಬಹುದು ಹೇಳಿ ನಾವು? ಎಂತ ಎರಡು ಟರ್ಮ್ಸ್ ಆಡ್ ಮಾಡಬಹುದು? ಎರಡು ಟರ್ಮ್ಸ್ ನೀವು ಆಡ್ ಮಾಡ್ತಿದ್ರಂದ್ರೆ, ಅಥವಾ ಎರಡು ಟರ್ಮ್ಸ್ ನೀವು ಸಬ್ಟ್ರಾಕ್ಟ್ ಮಾಡ್ತಿದ್ರಂದ್ರೆ, ಅಥವಾ ಎರಡು ಟರ್ಮ್ಸ್ ನೀವು ಈಕ್ವೇಟ್ ಅಥವಾ ಕಂಪೇರ್ ಮಾಡ್ತಿದ್ರಂದ್ರೆ, ಪ್ರೊವೈಡೆಡ್ ಆ ಎರಡೂ ಟರ್ಮ್ದು ಡೈಮೆನ್ಷನಲ್ ಫಾರ್ಮುಲಾ ಸೇಮ್ ಇರಬೇಕು. ದೆನ್ ಓನ್ಲಿ ವಿ ಕ್ಯಾನ್ ಆಡ್, ವಿ ಕ್ಯಾನ್ ಸಬ್ಟ್ರಾಕ್ಟ್, ಯು ಕ್ಯಾನ್ ಕಂಪೇರ್ the number of terms. Otherwise you can't add two dimensionally incorrect terms. You can't subtract two dimensionally incorrect terms. You can't equate two dimensionally incorrect terms. Dimensionally incorrect ಇತ್ತು ಅಥವಾ ಎರಡು ಟರ್ಮ್ದು ಡೈಮೆನ್ಷನ್ಸ್ ಬೇರೆ ಬೇರೆ ಇತ್ತು ಅಂತಂದ್ರೆ ಅಂತ ಟರ್ಮ್ಸ್ ನ ಆಡ್ ಮಾಡ್ಲಿಕ್ಕೆ ಆಗಲ್ಲ, ಅಂತ ಟರ್ಮ್ಸ್ ನ ಸಬ್ಟ್ರಾಕ್ಟ್ ಮಾಡ್ಲಿಕ್ಕೆ ಆಗಲ್ಲ, ಅಂತ ಟರ್ಮ್ಸ್ ನಾವು ಈಕ್ವೇಟ್ ಮಾಡ್ಲಿಕ್ಕೆ ಆಗಲ್ಲ. ಸೊ ದಟ್ ಈಸ್ ದ ಸ್ಟೇಟ್ಮೆಂಟ್ ಆಫ್ ವಾಟ್? ಪ್ರಿನ್ಸಿಪಲ್ ಆಫ್ ಹೋಮೋಜಿನಿಟಿ. ಲೆಟ್ ಮಿ ಟೇಕ್ ಒನ್ ಸಿಂಪಲ್ ಎಕ್ಸಾಂಪಲ್ ಹಿಯರ್. ಐ ಹ್ಯಾವ್ ಎನ್ ಇಕ್ವೇಶನ್ a is equals to b plus c. I have an equation a is equals to b plus c and this equation is dimensionally correct ಅನ್ಕೊಳ್ಳಿ. ಈ equation dimensionally correct ಇದೆ. According to principle of homogeneity, ಏನು ಹೇಳುತ್ತಂದ್ರೆ when you are adding b to c, you are adding b to c, you are adding b to c because dimensions of b and dimensions of c are same. ಇಲ್ಲಿ b ಮತ್ತು c ದು ಎರಡು ಡೈಮೆನ್ಷನ್ಸ್ ಸೇಮ್ ಇರೋದ್ರಿಂದನೇ b ನ c ನಲ್ಲಿ ಆಡ್ ಮಾಡಿದ್ವಿ. Suppose if b and c have, suppose if b and c have different dimensions, then it is impossible to add such two terms of different dimensions. ಬೇರೆ ಬೇರೆ ಡೈಮೆನ್ಷನ್ಸ್ ಇರುವಂತ ಟರ್ಮ್ಸ್ ಅನ್ನ ಆಡ್ ಮಾಡಲಿಕ್ಕೆ ಬರೋದಿಲ್ಲ. ದಟ್ ಈಸ್ ದ ಸ್ಟೇಟ್ಮೆಂಟ್ ಆಫ್ ವಾಟ್? ಪ್ರಿನ್ಸಿಪಲ್ ಆಫ್ ಹೋಮೋಜಿನಿಟಿ. ಅಷ್ಟೇ ಅಲ್ಲದೆ ಇಲ್ಲಿ a is equals to b plus c is a given equation. One more condition, all the terms in the equation should have the same dimensions. ಎಷ್ಟು terms ಇದ್ದಾವೆ ಎಲ್ಲದರದ್ದು dimension same ಇರಬೇಕು. ಅಂದ್ರೆ what is the meaning of this one? Dimensions of A should be same as dimensions of B should be same as dimensions of C. Means dimensional formula of A ತಗೊಳ್ರಿ, dimensional formula of B ತಗೊಳ್ರಿ, dimensional formula of C you consider, all should have the same dimensions. So that is the principle of homogeneity. So this equation is dimensionally correct. Which equation? V is equals to U plus AT is dimensionally correct. Now first point ತಗೋತೀನಿ, U is added to AT. U ಅನ್ನ AT ಗೆ ಆಡ್ ಮಾಡಿದ್ರಿ. ಯಾವಾಗ ಆಡ್ ಮಾಡ್ಲಿಕ್ಕೆ ಪಾಸಿಬಲ್ ಹೇಳ್ರಿ ನಾನು? Dimensions of U should be equals to dimensions of AT. U ಮತ್ತೆ AT ಇದ್ದು ಎರಡರದು ಡೈಮೆನ್ಷನ್ಸ್ ಸೇಮ್ ಇರೋದ್ರಿಂದ ಮಾತ್ರ U ಅನ್ನ AT ನಲ್ಲಿ ಆಡ್ ಮಾಡಿದ್ದೀರಿ. Suppose if U and AT have different dimensions, then definitely such two terms cannot be added in science. That equation is not dimensionally correct here. So U and AT are added here because they have the same dimensions. ಅಷ್ಟೇ ಅಲ್ಲ, in this equation dimensions of V, dimensions of U and dimensions of what? AT is same. ನೀವು ಬೇಕಾದ್ರೆ ಚೆಕ್ ಮಾಡ್ರಿ. What is V here? Velocity. What is the dimensional formula for velocity? m0 L1 t power minus 1. Okay, velocity. Next term ಏನು? U. U is called initial velocity. Its dimensions is m0 L1 t power minus 1. Next term ಏನಿದೆ ನಮಗೆ? AT. What is AT? A is called acceleration and T is called time. Acceleration dimensional formula m0 L1 t power minus 2. It is the dimensional formula of acceleration. What is the dimensional formula of time? Time dimensional formula is t power 1. ಏನಂತ ಹೇಳ್ರಿ? m0 L1 t power minus 2 t power 1. It is t power minus 1. Look at the terms. This is the dimensional formula of V. This is the dimensional formula of U. This is the dimensional formula of AT. Okay, all have same dimensions. m0 L1 t minus 1, m0 L1 t minus 1, m0 L1 t minus 1. Therefore this equation is correct. ಇನ್ನೊಂದು ನೋಡಿ, U is added to AT. U ಅನ್ನ AT ನಲ್ಲಿ ಆಡ್ ಮಾಡಿದ್ರಿ. U is added to AT. Why? Because U and AT both have same dimensions. ಇವೆರಡು ಡೈಮೆನ್ಷನ್ಸ್ ಸೇಮ್ ಇರೋದ್ರಿಂದ ಅವನ್ನ ಆಡ್ ಮಾಡಿದ್ವಿ. ಇಲ್ಲಿ ಕ್ವಶನ್ ಬರುತ್ತೆ, ಫೋರ್ಸ್ ಅನ್ನ ವೆಲಾಸಿಟಿ ನಲ್ಲಿ ಆಡ್ ಮಾಡಬಹುದಾ? ಫೋರ್ಸ್ ಅನ್ನ ವೆಲಾಸಿಟಿ ನಲ್ಲಿ ಆಡ್ ಮಾಡಬಹುದಾ? Is it possible for you to add F and V? Answer is no. Why? Because force and velocity have different unit as well as different dimensions. That's what they cannot be added. Force na acceleration alli add ಮಾಡಬಹುದಾ? Answer is no. Force cannot be added to the acceleration because force and acceleration have different dimensions and different units. ಎಂತ physical quantities add ಮಾಡಬಹುದು ಹೇಳಿ? You are adding 2 or more physical quantities ಅಂತಂದ್ರೆ they must have the same dimensions, then only we can add such type of terms in physics it is. So that we'll call it as a what? Principle of homogeneity. Once again, will you recall the statement of the principle of homogeneity? What is principle of homogeneity? 2 or more terms can be added, 2 or more terms can be subtracted, 2 or more terms can be equated or compared, provided they must have the same dimensions. So this is called the principle of what? The homogeneity. Okay, so based on this principle of homogeneity, the many questions are coming in your competitive examination Let me take such type of examples which can appear in what? Your competitive examination. Let me take one by one examples here. So I have one example here. So based on principle of homogeneity, what are the dimensions? What are the dimensions? Dimensions of constants. Constants A and B. A and B in an equation. In an equation, I have one equation. The equation is given. That equation is P plus A by V square into V minus B, which is equals to what? R. This is the given equation. In that equation, in this equation, we have to find what are the dimensional formula of the two constants. One is A and another one is B here. Of course, they will give the meaning of the terms here. Meaning of the terms is P is pressure of a gas, V is called volume of a gas. In general, P is called pressure, V is called volume, R is a constant called universal gas constant, and T is a temperature. A and B are the constants. P pressure is V volume, R universal gas constant, and T is temperature. In this equation, they are asking you to find the dimensional formula of the constants A and B. How you are solving? Very simple. Notice, P is added to A by V square. P na A by V square add ಮಾಡಿದ್ದೀವಿ. Okay na? As I said you, two terms can be added provided they should have the same dimensions. ಯಾವುದಾದ್ರೂ ಎರಡು ಟರ್ಮ್ ನ ಆಡ್ ಮಾಡ್ತೀರಿ ಅಂದ್ರೆ ಅವೆರಡು ಟರ್ಮ್ ಡೈಮೆನ್ಷನ್ಸ್ ಸೇಮ್ ಇದ್ರೆ ಮಾತ್ರ ಆಡ್ ಮಾಡಬಹುದು. ಅಂದ್ರೆ P is added to A by V square ಅಂದ್ರೆ ಅರ್ಥ ಏನು? Dimensions of P should be equals to dimensions of what? A by V square. Dimensions of P should be equals to dimensions of A by V square. ಅಂದ್ರೆ ಏನು ಬರೀಬಹುದು ನಾನು? Dimensionally, I am talking dimensionally, not mathematically. Dimensionally, P is equals to what? A by V square. Dimensionally, P is equals to A by V square because we are added these two terms provided they must have the same dimensions. ಅಂದ್ರೆ ಏನು ಬರೀಬಹುದು ನಾನು? Dimensionally what? Dimensions of P. Dimensions of P should be equals to what? Dimensions of which term? A by V square. So dimensions of P is equals to dimensions of A by V square. So this is enough for us to determine the dimensional formula of the first constant, that is A here. Andre dimensionally ಏನಾಯ್ತು ಇಲ್ಲಿ? Dimensionally P and P is equals to what? A by V square, because these two terms are added here. Therefore, what is A? A is equals to PV square. Dimensionally A is equals to PV square. Then A is equals to what is P? Pressure. The dimensional formula of pressure is force by area. M to the power 1, L to the power minus 1, T to the power minus 2. This is the dimensional formula for pressure. Volume. Volume is L3. The dimensional formula of volume is L cube. Square ಇರೋದಕ್ಕೆ it will be L cube square. It will be L to the power 6. Okay, then what is the dimensional formula of A here? The dimensional formula of A should be equals to M1 L minus 1, L 6 here. Therefore, it will be L to the power 5 into T to the power minus 2. So, this is the dimensional formula of the constant A here. Okay, got my point? Yes? Then, I want to know the dimensional formula of another constant, that is B. Here, B subtracted from V. B subtracted from V. When the two terms can be subtracted, provided they should have the same dimensions. Andre, dimensions of V should be equal to dimensions of B. Andre, ಏನು ಮಾಡಬಹುದು ನಾವು? Dimensionally, not mathematically. Dimensionally, ವಾಲ್ಯೂಮ್ ಮತ್ತೆ ಬಿ ಎರಡು ಈಕ್ವಲ್. ಯಾಕಂದ್ರೆ ಎರಡನ್ನು ಸಬ್ಟ್ರಾಕ್ಟ್ ಮಾಡಿದ್ರೆ ಅಂತಂದ್ರೆ ಎರಡರದ್ದು ಡೈಮೆನ್ಷನಲ್ ಫಾರ್ಮುಲಾ ಏನಿರಬೇಕು? ಸೇಮ್ ಇರಬೇಕು. Therefore, dimensional formula of V should be equal to dimensional formula of what? B. What is V? Volume. Therefore, what should be the dimensional formula for B? The dimensional formula for B should be equal to dimensional formula for V. Andre dimensions of B is equals to dimensions of V. Then what is the dimensions of B here? Dimensions of V. V andre volume. Volume andre L to the power 3. L to the power 3 means M0, L power 3 and T power 0. So this is the dimensional formula of the constant. Or question ಏನು ಕೇಳಿದ್ದಾರೆ? What are the dimensions of constants A and B in an equation? ಈ equation ನಲ್ಲಿ A ಮತ್ತು B ದ dimensions ಏನಿದೆ ಅಂತ ಕೇಳಿದಾನೆ. Dimensions of A is M1, L5, T power minus 2 and dimensions of B is M0, L3, T power 0. Okay? Let me take one more example here. I have one more equation here. Velocity V is given by AT plus B divided by T plus C. Velocity V is equal to AT plus B divided by T plus C, where A, B and C are constants and T is time. What are the dimensions of A, B and C? Information ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ? Velocity V is related to the equation AT plus B divided by T plus C. In this equation, A, B and C are the constants here. A, B and C are the constants, and they are asking you to find the dimensions of what? A, B as well as C. Here the concept ಏನು ಹೇಳುತ್ತೆ? What is the concept? Okay, according to principle of homogeneity, all the terms should have the same dimensions. First of all, ಎಲ್ಲ termದು dimensions same ಇರಬೇಕು. ಅಂದ್ರೆ ಅರ್ಥ ಏನು? Dimensions of V should be equals to dimensions of AT should be equals to dimensions of what? B divided by T plus C. ಇಲ್ಲಿ V the dimension, AT the dimension ಮತ್ತೆ B divided by T plus C dimension. ಇವು ಮೂರದು dimensions ಸೇಮ್. ಅಂದ್ರೆ ಫಸ್ಟ್ ಪಾರ್ಟ್ ಏನು ತಗೋದು? Dimensions of V is equals to dimensions of what? AT. ಈ v ಮತ್ತು at ಎರಡರದ್ದು ಡೈಮೆನ್ಷನ್ಸ್ ಸೇಮ್. ಸೊ ಡೈಮೆನ್ಷನ್ಸ್ ಆಫ್ v, what is dimensions of v? Velocity m0 L1 t power minus 1, which is equals to a as it is, because we don't know the dimensions of a, into t is time, that is t power, okay, s. Then transfer this side. A is equals to m0 L1 t power minus 1, it is t power plus 1. Take t power plus 1 to the numerator, then a is equals to m0 L1 t power minus 2. So this is the dimensions of what? A. Okay na? Now next one, t is added to c. t is added to c. t na c ಗೆ ಆಡ್ ಮಾಡಿದ್ದೇವೆ. ಓಕೆ ನಾ? ಪ್ರಿನ್ಸಿಪಲ್ ಏನು ಹೇಳುತ್ತೆ? two terms can be added. So here t is added to c, which means dimensions of c should be equal to what? Dimensions of t. So because you know very well, when the two physical quantities can be added, provided they should have the same dimensions. Therefore dimensions of c should be equals to dimensions of what? T. So dimensions of c should be equal to dimensions of t. What is t here? T is a time. Therefore the dimensional formula of c is time. Next I want to determine the dimensional formula of b here. To determine the dimensional formula of b, I will take statement of what? Principle of homogeneity. ಏನು ಹೇಳುತ್ತೆ principle of homogeneity? All the terms in an equation should have the same dimensions, which means dimensions of b divided by t plus c should be equal to dimensions of v. So dimensions of v should be equal to dimensions of at should be equal to dimensions of what? b divided by t plus c. ಈ b divided by t plus c ಮತ್ತೆ v ಇವೆರಡರದ್ದು ಡೈಮೆನ್ಷನ್ಸ್ ಸೇಮ್ ಇರಬೇಕು. Therefore what I can write? Dimensionally b divided by t plus c should have the same dimensions of what? V. Therefore what is b here? b is equal to, transfer this side, it will be vt plus what? vc. If you transfer t plus c to that side, it will be vt plus vc. Now what is the dimensions of b? Dimensions of b should be equal to dimensions of vt. Once again, all the terms should have the same dimensions. ಇಲ್ಲಿ b dimension, vt dimension, vc dimension ಎಲ್ಲ ಸೇಮ್ ಇರಬೇಕು. Therefore what is the dimensions of b here? Dimensions of b should be equals to dimensions of what? v. Okay na? v. What is v here? v andre velocity. Velocity is m0 L1 t power minus 1. What is t? t is time. t power plus 1. t power minus 1 plus 1 gets cancelled. Then what is b? The dimensions of b is m0 L1 t power 2. Therefore a has a dimensions of acceleration. m0 L1 t power minus 2 is a dimensional form of acceleration. c has a dimensions of time and b has a dimensions of what? Length. Such type of problems can be solved based on principle of homogeneity. Okay.